Okay, good evening, guys. Hope you all doing well. Am I audible to all of you? Am I audible? Yeah, fine. Thanks for responding. Okay, let's continue today's class. Yesterday we have discussed about the basics of StatPro. What are the features available in the StatPro Connect edition? And we have seen the difference between V8i edition and Connect edition. So let's continue today's topic by continuing yesterday's topic. Okay, so let's move on to the today's session. Okay, let me share my screen. Yeah, fine. Is my screen visible to all of you? Yeah. Is my screen visible to all of you? Fine. Look, can anyone respond? Is my screen visible to all of you?
Yes.
Yes, fine, fine. Thank you. Okay, let's. Yesterday we have seen up to specifications tab. So we have seen what are the supports available, what are the sections we can do. We have seen yesterday's class. Let's move on to the next tab, loading tab. Okay, in this loading tab, there are some certain cases you are seeing here. Okay, so primary load case, load combinations, reference load case, load items, etc. All these. Okay, so the primary load case is nothing but a simply you can call independent loads like individual load, simply you can say dead load, live load, wind load, uh, etc. Seismic load, temperature load, roof live load, or mezzanine live load, etc. All these individual loads comes under primary load cases. Okay, and the second one you are seeing combination load case. Combination load case is nothing but if you are using S800 or if you are using ASC75 something, if you are using any country code, there will be some certain combinations, right? Suppose if you take working stress method or if you take allowable stress method. Okay, dead load plus live load. One will be the partial safety factor for both these dead load and live load like that. So there will be some certain load combinations in order to design a structure. That is about combination load case. So you have to design a particular structure by using load combinations only. You could not design any structure with independent load cases. Okay, so you have to use load combinations only. Like that, if you go to table number 4 in IS 800, you can find partial safety factors, and you have to derive the load combinations from the table 4 like that. Every code will have some certain load combinations based on their specifications, so you have to use that one. Okay, wherever applicable. And the next one is reference load case. Reference load case is nothing but it is an independent load case which could not be considered in the design. Suppose when it will be useful. Suppose if you are finding a spring constant. Okay, if you are finding a spring constant for a beam, I think all of you know about spring constant. Spring constant which will show you the deformation per load. Okay, so if you are applying 1 kilonewton load on a particular beam, it shows how the deformation or the how the deflection will be. That will be the spring constant K. Generally it will be denoted by K, and it will be denoted in the units mm per load. Okay, or deflection per load, you can say. So for the calculation of spring constant or for the calculation of anything, okay, and if you don't want to use the load in load combination, you have to use the reference load case here. Okay, this load item is a secondary load case which will not be useful in our sessions. Okay, and load generator, it will be only for moving loads. Okay, if you are designing a bridge, if you are designing a footway, etc., all these you have to use load generators. And in that you can say you can define primary load types. What are the primary load types available? Seismic, first one, seismic positive X, seismic negative X, and dead load, live load, collateral load, wind load, temperature loads, etc. All these things. And auto load, auto combinations. Auto combinations is nothing but the StatPro itself will give it will suggest the load combinations with respect to the primary load cases you have defined here. So it will give auto combinations. It will give you the values of partial safety factors accordingly what you have given in the primary load types. And these are all about if you want to create a primary load case as wind, if you want to create a primary load case as snow, seismic, direct analysis, vehicle, pushover. Pushover is nothing but it's a technique to use the deformation due to seismic. Okay, so it is a non-linear technique generally we'll use. Okay, we'll not use pushover analysis, all these things in our sessions. And these are all related to seismic. Generally we use static analysis only, so this will not be in our scope. And the next go to analysis and design tab. Analysis commands. What are the analysis commands you need to give? Nothing but if you want to print output at a maximum level, if you want to print output at a minimum level, if you don't print if you don't want to print the results in the output tab, you have to give all these in the analysis commands. Okay, there are some certain pre-analysis commands, post-analysis commands. Pre-analysis commands are nothing but the design parameters in which you have to give. Post-analysis commands is nothing but about the scale takeoff, check code, etc. All these things. Okay, miscellaneous commands, we will not use all these things. If you see input width, output width, ignore list, all these things. Set_nl is a command which will be useful if you have much more load combinations. Nothing but if you have exceeded 200 numbers of load combinations in your input file, generally directly it will not take stat. So you have to use set_nl command. Like that, there are some certain commands are there. These are called miscellaneous commands. And the load list. Load list is a particular command or a particular parameter in which you have to give what are the load cases or what are the load combinations you want to run in a particular methodology. Either it is LRFD or it is ASD. If you take ASC, it is LSD or it is WSD if you take IS 800, like that. So load list is nothing but it is a representation of load numbers. What are the loads you are going to give, the combinations which the design in which the structure has to be designed. So load list is a command in which the load combinations has to be executed in our design. Okay, so load list is the particular command. It is the main command generally we use. And the run analysis, okay, this is all about compilation and run the program. It will run the program. Run analysis is a command. So all these things, design commands for steel differently. There are certain commands for steel, concrete, and aluminum. All these things. Okay, we'll see one by one. So if we are designing a beam, we see what are the input commands we need to give to design a beam in the StatPro. So like that, we'll see all these things. And in the utilities tab, okay, utilities tab, it is the structural tools. First, you see structural tools, multiple structures. Multiple structures is nothing but if you have structure, if your structure has any disjoint, okay, nothing but if you are doing multiple structures at a time or side by structures at a time, you have to use the structural tools whether it is disjointed or connected. Okay. And the other thing, merge properties. Merge properties is nothing but sorry, someone Deepak. Okay, Deepak, could you please just take care of yourself? You are drawing some certain lines in the screen. Okay, fine. And the next one is coming to node tools. Node tools is nothing but duplicate nodes. Duplicate nodes is nothing but if you have any overlapping nodes, nothing but a node on another node. Like that, if you are having any duplicate nodes, suppose if you suppose I'll show you one thing here. So I have one node at origin here and the other at 5 meters like yesterday, and the same other at 5 meters yesterday. So you will be having two nodes. Okay. So at the same point, you will be having two nodes. In that case, it will be this structure. Okay. So this duplicate nodes command is this duplicate node feature is useful in finding the duplicate nodes. So if you see like this, it is showing, right? 2 and 3 nodes are duplicated, nothing but they are at the same point. If you want to merge, you can merge here. Okay. So if what node you want to keep, only second node, it's okay. So it is created only one node. The other node is deleted here if you see. So like that node tools and any orphan nodes. Orphan nodes is nothing but while you are designing a structure, mistakenly you have created a node which is not connected to the structure. So that can be called as orphan node. Okay, an orphan node which is not connected or which is not related to our structure can be orphan node. Okay, if you want to remove those orphan nodes, you have to use this command and node to node distance. Suppose okay, we have two nodes here. Generally, every time you cannot go to geometry and you cannot find the distance in between them. So this node to node distance will be useful here. If you click node to node distance, so in similar way, dim linear command you are using in the AutoCAD, you can now you can use here node to node distance command. Okay, that will show you the distance between any two nodes here. If you see, it is showing 5 meters here like this. Okay, the another tool, remove node to node distance. If you click this, the node to node distances will disappear here. Okay, this is all about node tools, and we will widely use this command. Okay, and the next command, beam tools. If you go to beam tool specification, there are some certain things. Duplicate beams. Duplicate beams is nothing but if you have doubt of any beam running over another beam, you want to find the duplicate beam, you have to use this command. Like we have seen duplicate node like that only. Zero length beams. Zero length beams, some nothing but if you are connecting beams these between these two nodes, probably due to some particular instruction, you have moved this node to some at this particular distance. So suppose let me show you an example. You have connected a beam between these two nodes, right? So you have moved this node to again origin due to some particular instructions. Okay. So okay, so it will show you the duplicate nodes command here. Directly it is warning. Okay. So So if you want to keep it like that, if you you can keep it like that. So if you want to beam tools, zero length beams, you can find any zero length beams. If you click OK, it is showing the beam number 1 is having zero length. Okay, if you highlight, it will show you a beam here. Okay, if you want to delete it, you can delete. Okay, only node is there, beam is deleted. Like that, zero length beam tool will be helpful. Overlapping collinear beams. If you are doing any collinear beams is nothing but any beams running on the same line. So if you are beaming running like this, and second one is doing from this to this one, so these two can be called as collinear beams. So one beam starting point is here, ending point is here, and the another beam starting point is here, ending point is here. So these two beams can be called as collinear beams. If these two beams overlap, it will detect. Okay, this is called overlapping collinear beams check. And the beam incidence is nothing but I told you already, shift E. Okay, which is the starting point and ending point to check the beam incidence. Okay, shift E command will be useful. If it is in the green color, that is the starting node. If it is in the blue color, that will be the ending node of the beam. Like that. Dimension beams, it will show dimensions of beams. Suppose if you have two nodes like this, we have a beam like this. So if you click dimension beam, dimension to view display, it is showing one beam number 1. Okay, this is beam number 1. Beam number 1 having 5 meter length. So it is showing like this. Okay, so if you want to remove, you can remove like that. All these plate tools and solid tools, all these will be in RCC structures only. Okay, and the another one, display inserts text. If you want to put any text here, so you can give it like this. So it will show you a particular text here. Okay, so another command, command file is nothing but generally we can call it as editor. Okay, STAD editor. Okay, if you click this, a programming tab will open. Okay, like this. Okay, nothing but if you say any C programming like that, if you have seen in your BTech life, so it will be the same as like that. Okay, have you ever programming while doing? I think people who have done inter and after having inter and come to BTech or BE, they can observe. They'll some people will have C language in their curriculum. So the people, they can understand what is the programming. So they'll give a certain tab like this. You have to execute the program and you have to compile the program. You have to run the program. The same way, STAD also works here according to the STAD editor. Okay, so we have to give a particular commands in this tab. Suppose perform analysis. Okay, suppose I'm giving an example. Okay, perform analysis and check code. Okay, all these things you can give. Okay, these are the commands you need to learn. Okay, I'll show you how to do a program in the STAD editor, because all the companies will give or will do design based on the STAD editor only. Okay, so that's why it is very important to learn how to design a structure using STAD editor. So simply this is a command file. Okay, this dialog box can be called as command file, or otherwise we can say in other terms it can be STAD editor. Okay, so suppose what is the basic advantage of this STAD editor? You know, if you copy all these text, okay, if you copy all this text any other STAD file, the program automatically will come there. Okay, so if you have copied this text into some another file, okay, suppose if you copy this text into suppose I'll create a new file. Okay. So I'm creating a new file here. So I'm opening stat editor, or we can say it as command file. So okay, I have pasted all the text from the previous stat file. If you close it here by saving, you can observe the same beam came here. Okay, so like this, only by copy and pasting the text, you can you can do an entire program. That is the advantage of this stat editor. Simply you can save it in a text format if you want. That is the basic advantage of stat editor. Okay, so this is all about command file. In the next one, we are having analysis output. Analysis output is nothing but after doing analysis. So if you have given properties and if you have given loads and load combinations, you have given entire the parameters based on the codal properties. So you have done analysis. After that, the stat program will create an output for you. Okay, whether the beams are passing or whether the what is the shear maximum shear value in a beam, what is the maximum bending moment value in a beam, and it will create a report. The report can be called as analysis output. Okay, in the analysis output itself, what is the weight of this beam or what is the weight of the structure you got, all these details can be found in a analysis output. This error log will be in the part of analysis output only. What are the errors you got, where are the and where you got errors, what is the line of the error, you'll get all these things. Okay, these are all basics, calculator, unit converter, etc. All these macro editors is just it is out of our scope, because macros is nothing but virtual basic analysis, something VBA macro editors are there. No, you have to give in deep program. So in Excel also there will be macro editors, right? So like that only these macros will work. Okay, generally we will not use all these things. Okay, so this is all about a stat pro basics. Okay, so let's go to the main component. So how to design a particular beam. So suppose I am taking this beam of 5-meter length. Okay, I am taking this beam of 5-meter length. Before going to the analysis, so I think what is the analysis and what is the design, I think most of the people you know, right? So analysis is nothing but you are analyzing the structure, nothing but you are analyzing a structural behavior under the different loads, that can be called as analysis. Okay, so what is the design? So design is nothing but after analyzing the structure, you if you have given any properties of to the structure, so you have given some certain properties like this much of I section, this much of web depth, this much of flange width. So you have given any properties, whether that section is safe or not, it will tell you. Okay, that is the design case here. So first of all, we have to do analysis. After that, we'll go to design, whether it is safe or not, we will see. So okay, for that, I am doing a simple, or I can say a simply supported beam. Okay, so a simply supported beam of 5-meter length. So okay, I have created. So first of all, I'm doing from starting point. I'm deleting all these things. So this is the starting one. So after opening the start view, after creating a new file, you'll get all this interface, right? So first of all, you have to create a particular node. I'm taking a particular first node or starting node at origin. Okay, so you can create node by using geometry command. Okay, here you can see a tab. Okay, nodal tabs and beam tabs here. Just guys, please one request from me. If you are coming into the session, please mute yourself because that will cause some disturbance to the others. Okay. So this time I'm doing, just take care of yourself from the next time. Okay. This is a gentle request. Okay, because we should not cause any disturbance to the others, right? Fine. Okay, so I'm creating or I'm taking a starting node at the origin 0, 0, 0, and I want to create a beam of 5-meter length, right? So first of all, if you see the UCS here, Universal Coordinate System here, so what is the view it is showing? It is showing firstly isometric view. The view in the default view in the StatPro is isometric view, and the default cursor in the StatPro is beam cursor. Okay, these two are the things you have to remind all the time. Okay, so the view is isometric view, default view is isometric view, and default cursor is beam cursor. So in order to take node cursor, you go to select tab in here. You can select node cursor. After that, you can select any node in the UI or user interface, I can say. Okay, user interface. Otherwise, there are some certain shortcuts if you want to create. Okay, so if you press spacebar, this feature is only the additional in the StatPro Connect edition. There is no such feature in the StatPro 8 edition. They have included this feature. Okay, if you press spacebar option here, it will show a particular types of commands. You can add the commands as your wish. Okay, so what are the commands generally you use? Okay, because I have selected all these commands in my quick list. Okay, I can say this as a quick list. I use generally command file. I used to see output regularly, and I use it to have the default cursor is node cursor, right? So you no need to mention node cursor, beam cursor here. The default cursor is beam cursor, so no need to create a beam cursor here. So instead of I have used node cursor, I have used translational report, I have used front view. These are all generally regular usable commands. Okay, that's why I have created all these in a quick list. If you don't want anything, you can move it like this. If you select that one, if you click this one, it will go to the other side. Nothing but if you you will not have in your quick list. Okay, this is all the quick list items you can add in the quick list tab by creating by clicking the space bar option. Okay, so I have used those commands. So that's why if I click space bar, it is showing all these shortcuts. Okay, so
Excuse me,
just tell me.
Hello.
Yes.
Sorry for the interrupt. Somebody made the display on the topmost right of the screen.
Again, huh?
Yeah.
Who is that? I'll show. I'll say. Whose video is that? No. No one's video is there. So all of you getting the same problem, right? Some video is displaying on the screen, huh?
No. There is no video on this.
Video, it's like a image.
Huh?
It's like an image, icon image.
Sorry, I'm not getting your voice properly. Can you speak with some loud?
It's not a video, it's an image.
It's a
image like a black image is like icon.
So any image, any other seeing the image?
That is recording section. Icon.
Recording section icon. Okay. Any other thing you are seeing? No.
Nothing.
No, sir.
No, sir. No, sir.
No. Okay. Fine. Maybe that is the recording section icon. You will not get in your recordings.
Left side, I think left side is the recording section. And the topmost right is showing the black icon.
Sorry, I don't have anything here in my screen. Okay. As of now, I don't have anything black or anything dark colored concept in my screen. So if you feel others also the same thing, if you feel others, the same can be informed to me. No, I think, yeah, yes, please.
I have clear, sir.
You have clear. So maybe something from you, sir, actually. Okay, maybe that is something from you. All the others are clear, they are telling. Okay, so you will not get any disturbance in the recording section. Okay.
No. I can't. No problem.
Okay, sure. So I'm continuing. So, okay, fine. Let me continue. So if you have any problem, please feel free to ask me, because it will get recorded. You should not get any such disturbance, right? So, okay, let me continue. So I have created a node at a origin. So, typically I want to use the maximum number of commands to understand, right? So, okay, first of all, I have created one node by using geometry here. Okay, another command I'm going to use here is I have to use a node cursor. That's why I have clicked spacebar on the UI. So the shortcut or quick list is appeared here. In that, I am taking a node cursor here. So node cursor appeared here. So by that node cursor, I have selected one node and I have copying and pasting. So Control C and Control V. I'm using the command. Okay, Control C and Control V. If you click Control C and Control V, you'll get a dialog box like this. Okay, so paste with move like that. Okay, you can give node to node distance here. Otherwise, you can give geometrical distance here. So if you want to create a node at 5 meters from the selected node, so I am giving 5 meters x distance. If I click OK, so 5 meters distance x distance, it has created a node. So if you see, there are two numbers of nodes. One is here, one is here. So after this, because we are doing a beam only, beam is a just 2D structure. Okay, so I'm going to use only front view only. Okay, that is XY plane is enough for me. I'm not interested in the concept of using Z direction. That's why I'm using XY plane only. Is someone unmuted again? Okay. Okay, fine. Sorry for the disturbance. Okay, so I have selected these two. Sorry, this is all about viewing. So I'm talking about viewing, right? So I have to use XY plane only. That's why I have to select front view section. So if I click again spacebar, I have front view in my shortcut list. Okay, so if I click front view, so you have seen, right? XY plane is only appeared here. Z is nothing but perpendicular to the screen. So this is all about front view. You can see straight line. Nodes are in the same line, right? So this is all about front view. So I am going to connect these two nodes with a beam command. So in the geometry tab, it is an add beam command. So I'm taking add beam command. I'm joining these two nodes like this. So There is another way you can join these two nodes with another command. For that, I'm deleting this node. Okay, so you have to select these two nodes first. There are number of possibilities you can do. All the possibilities I'm explaining here, don't confuse between. Okay, so after selecting these two nodes, there is one command here. Yesterday I told you connect beams option. Okay, if you drop down a menu, so in which axis you want to connect the beams? Along the x-axis. So if you click x-axis, one number is created. Okay, with the number of beam number 1. Okay, so how to see beam number? If you click shift B, you can see beam number. Or if you click shift B again, it will hide it. Okay, if you want to see the numbers, node numbers here, shift N. Okay, first node, second node here. Okay, so if you click shift N again, the numbers will hide. Okay, like that. So this is all about creating a geometry. And the next thing, okay, this is all about these all things in a particular design manner. So you can use directly one by one. Okay, after one another, after you can use directly. Okay, these are in the design manner only. So I have completed geometry here. So next thing, if I go to properties, so what is the properties section we have seen? That is defining a section. Okay, suppose I am going to use a particular welded section or built up section, I can say. So I am going to use a particular built up section. Built up section is what is the built up section? Built up section will be formed by using or by connecting a different flange plates and web plates. Okay, so simply they will weld each other. Like that, they'll form a built up section. Okay, so I am going to define that built up section. Okay, so in this there are certain edit, delete. If you have anything here, you can edit the section. If you have anything here, if you are not interested to assign this to one, so you can delete that section. There are some certain values. Okay, any properties you have defined, that will show you here. Section database is nothing but to create a section by using hot rolled member. Okay, hot rolled member, you know, all of you. So hot rolled member is nothing but by using mold. They'll prepare a section by using molds. That is the hot rolled section. So every country, there will be some certain hot rolled steel. Okay, hot rolled and cold formed sections. All these sections are constant. We cannot change as our wish. They have given as per the provisions only. Okay, we cannot change it as our wish. So I'm going to avoid this hot roll section because we are all going to learn about PEB structure, right? PEB structures, you need to give tapered sections only because you want to minimize the weight. Conventional steel structures, you can use hot roll sections, no problem at all. ISMB, ISMB, like that you can use as your wish. In the PEB section, you have to use mostly tapered members only. In this, if you see define section here, I'm clicking the define section. So here one option is there: circle, rectangle, T, trapezoidal, all these things you can see. Because in the steel industry, most of the beams will be by using I section only. Okay, because I section will have much more capability of load bearing, right? That's why most of the beams you can see will be of I section only. So I'm going to define an I section, tapered I. Since it is a simply supported beam, I want to give a constant I section. So in the tapered I section command also, you can give constant I section by keeping the depth at both ends are same. Okay, so if you see here F1 is nothing but depth of the section at start node. So before going to that, you have to know what is the start node and what is the end node. Just I'm closing that. If you click Shift E command here, okay, Shift E, it is showing green color here, it is showing blue color here. So if you click define this one, I'm going to tap out I section. So depth of the section at start node. So what is the depth you want, depth of the beam you want to be here? Okay. So just suppose let us take web depth of 400. But what is the F1? You can observe closely. This diagram you can observe closely. F1 is nothing but out to out of flange. If you observe closely, F1 is nothing but out to out of flange. Suppose I have a web depth of 400. Okay. Suppose just I'll show you what is the section I want to take. After that, you can understand. I am going to first of all web. All of you see my notepad, right? So I am going to use the section of web 400 by suppose let us take 5. Okay, and of top flange. Okay, every I section will have 2 flanges, right? Top flange and bottom flange. So that is all about. This is about top flange of 150 by suppose let us take 6 mm, and I am using the constant section. Bottom flange also 150 by 6. So, okay, all the dimensions are in mm. Okay, clearly note, I have given all these dimensions are in mm. Okay, so this is the section I want to give. Okay, so how to give this section? So F1 is nothing but out to out of flange as discussed, right? So what is the flange thickness here? Okay, 6 mm. Top flange is 6 mm thickness. Bottom flange is of 6 mm thickness. Web depth is 400. Okay. So the web depth is 400 plus. Again, bottom flange is 6. So that combination gives you total depth of the section. 400 plus 6 plus 6. What is that? 412. If you see here, it is in meters. So I all these are in mm, right? So I want to give 0.412, right? 0.412 is the depth of section at the start node. And if you go to F2, thickness of web. So thickness of web. What is the thickness of our web? Web is of 5 mm thick, right? So it is showing in the meters. So how to give mm? 5 mm, 0.005. Fine. And F3, depth of section at end node. So again, it is also from out to out of flange. So again, 400 plus 6 plus 6, that gives you 0.412. Right? Width of top flange. What is the width of our top flange? In our example, this is 150 mm flange. Okay, so 0.150. Fine. And F5, thickness of top flange. What is the thickness of top flange? 6 mm thick. So 0.006. Okay, the same way, bottom flange also of 150 thick, and it is also of 6 mm. 150 mm of width, 6 mm of thickness. So the material selected is steel here. Okay, the material selected is steel here. I'm going to add this section and I'm closing this tab. So you have given a particular section. So of 400 by 5 web, 150 by 6 of flange. So you have created a section. Now you have to assign this section to this beam. So I have to click this section. Okay, I have to click this beam. Assign to selected beams, you have to choose assign, right? So I have assigned this section to this beam. Okay, so that's why property have been assigned. And you have given materials thickness, etc. User table will be generally useful in British standards. Okay, so generally directly, because in the British standards it will not take tapered section directly. You have to create an user table. Okay, British standards. you have to create user table. So doing in Indian and AS standards, no need of going for user table command. But if you want to design any structure on British standards, you have to create user table. Again, someone unmuted. Fine. Okay. After that, you need not to go to materials tab because we have already assigned the material is steel, right? Here you can see material of steel. So no need to go for material tab. And the next one is specifications. So what are the specifications your beam have? So we are talking about beam, right? If you click beam specifications, there are some set time: release, offset, property reduction factor, cable, truss, compression, beam, imperfection, five proofing, inactive, tension, all these things. Generally tension, cable, truss, all these things. Truss, you know, if I assign truss to this member, it will take compression, either compression or tension only, because truss member will not have any bending moment. So like that you have to assign. If I assign cable, okay, cable will take tension only, it will not take compression also, because if you compress the table, it will deform directly. You can observe it will deform a cable. So but if you apply axial tension force, it will take that is the property cable, property reduction factors, okay, offset, release, offset, release, all these things we'll see. Offset is nothing but generally STAD in while doing the STAD design in STAD Pro, generally will take center to center distance. But if you observe practically, okay, the beam will start at the out of the column. Generally, I'm telling you. So, but in the STAD, it will go from center to center line. So you have to give some offset command. Again, some disturbance.
Sir, one question here, sir. Suppose if I don't give offset, if I consider with center line, is there any effect on results, sir?
Yes, surely. Just a minute. I want to mute this guy. Okay. Yes, surely there will be some certain effect, because if you see, if you observe a beam here, okay, suppose I'm going to use offset command here just to explain you. Okay, I have here, before going to that, I want to know the entrance and sorry, start and ending point of the beam. So I'm going to beam specification. So in order to explain you, I'm taking just an offset. Okay, suppose if your column is having a 400 depth. Okay, so generally STAD, how the STAD will take, it will take from the center of the column, but practically this beam will start from the out of the column. So this 200 you can offset it. So if I click 0.2 meter, okay, start, green color is start, right? So location is start, offset is 200 mm, add, okay, and the other thing, the same thing you can also apply here, but this is the end portion, right? Okay, offset, you have to choose end, and this is about if you have to give offset in negative direction, okay, because x is positive towards right, negative towards left, so you have to give minus 0.2. Closely observe this one. So I have added these two commands. I'm assigning these two commands to our beam. Okay. Okay. If you observe this, what portion we have given offset, you got a hidden lines. Okay. Something I can say hidden lines. Okay. If you offset this beam, the load will not apply at this point, right? Technically, if you think technically, if we are applying load on the full length of the beam, and if you are giving offset, the load will be nullified here. Okay, thus it will the moment will get somewhat reduced. Okay, the moment in this beam will get somewhat reduced. Also, you are reducing the length. Okay, that's why load value, if you are giving UDL, suppose 3 kilonewton per meter of UDL for full length, and means 3 into 5, nothing but 15 kilonewton overall force. But what is the actual force? You are giving offsets 200 and 200 here. So 5 minus 0.2, 0.2, nothing but 4.6. So I'm going to calculate in front of you. So a 3 kilonewton per meter load into effective value is effective length is 4.6 here. So instead of 15, it will take 13.8 kilonewton force only. So the shear force also get reduced. The bending moment also will get reduced. Thus, the section will become somewhat economical. That is the sorry, someone asked about this thing, right? Have you understood clearly?
Yes, sir. Yes, sir. Yes, sir. Normally, I used to do like because it is time taking when we do it 3D.
Okay, if you are doing a 3D structure, it will be a time taking process. Yes, exactly.
Most of the cases, because even in mezzanine or steel buildings, I know that we can it will save some.
Yes, surely we can get the structure economical by using this, but it will be a time taking process. Exactly. So in the basic section, I don't want to give any offsets, so I'm deleting all these comments. Just I have explained all this to you. That's it. And we are not going to use any plate command here. And the next thing, if you are going to the supports, and yesterday I have told you a simply supported beam will have. Sorry, can anyone guess what are the supports to a simply supported beam? Generally, all the people, most of the people will say both are pinned connections. So that is wrong. Actually, if you talk technically, that is wrong. Okay. So actually, what will happen? A simply supported beam will have a pinned connection at one end, the roller at other end. Roller. So what is the difference between a pinned connection and a roller? So pinned connection is nothing but anyway we are releasing the moments. That is not the case. But what are the forces restricted in the pinned connection? Fx, Fy, Fz. All the axial forces or all the forces along the three directions, or you can say all the forces along three axes is stiffened. Okay, in the pinned connection. Whereas in roller connection, only Fy will be stiffened. You can also release Fz and Fx also. So what will happen if we take pinned connections on both ends? We'll see. Okay. First of all, a simply supported beam I'm designing, right? So I'm taking one pinned connection and one roller connection. So first of all, I'm creating a connection here in the create tab is there, no? I'm creating a connection. So here you can say pinned connection. I'm adding the pinned connection. This pinned connection you can assign to one node. So I am selecting first node. I am assigning pinned connection to that node. So if you observe, this is the pinned connection. So I have to assign roller connection to this. Okay. Roller connection to this. So I'm again creating a node, but this time instead of doing pinned, there is another option, fixed butt case. Okay, because I am using roller connection. Roller connection will take vertical load only, Fy. Okay, remaining all the loads can be released. Okay, so if you observe here, fixed butt, what are the components you want to release? It is asking. What are the components you want to release? Release is nothing but what are the components you have to fix? First, you have to know. Okay, I'm going to fix Fy only. Remaining all the components should be released. Fx, Fz, Mx, My, Mz. Anyway, Mx, My, Mz will be released in the pinned connection also. But in the roller connection, Fx and Fz also I'm releasing. So I'm going to add this support. So I'm assigning this support to this node. So if you observe, only Fi here, Fi support is there, right? So okay, this is all about simply supported beam supports. Okay, there is one drawing option is there, no, so that I can explain. Sorry. Yeah. So okay, I'm drawing here one beam. Okay, simply supported beam is nothing but, okay, you can generally do, and this is the other, you can see this is the Fi connection, like this we are using here. Okay, so only Fi will be there, the remaining components along Fx, Fz also released. Okay, that is all about roller support. Okay, and then next tab we are going to use loading. So just this is a simple beam. I'm giving dead load and live load only. Okay, so dead load. I'm using, I'm telling you based on analytical modeling. That's why I'm going to give all the commands here in the UI itself. Okay, I'm not using any command file or editor file here in this section. In another section, in another session, I'll going to explain you how to use the command file or editor file. Okay, so in this UI itself, I'm doing all these things. So in the load case details, definitions are nothing but if you want to give any vehicle loads or if you want to give any seismic loads, all these things you have to define first. Okay, so in that you have some particular definitions, all these things you have to give definitions. Also we will use this parameter in our PEBs. Okay, so how to use that I'll tell you. Because I'm doing a simply supported beam here, we are not going to define particularly anything, just I'm going load cases. Okay, I'm going with load cases. So click load case details, add one thing here. So first one, there are some certain things you can see here: primary load cases, load generation, define load combinations, auto load combinations. What are the primary load cases? I have told you already. These primary load cases are nothing but individual load cases. You want to give dead load, another one live load, another one wind load, another one seismic. All these things you have to define one by one. This is all about primary load cases. Load generation is for the moving loads only. Define combinations is nothing but if you want to define combinations by your own, you have to use this thing. This is about A1 is nothing but partial safety factor, all these things. Okay, L1 is nothing but load case detail. All these things you have to give. Okay, I'm getting some disturbance. Okay, fine. Auto load combinations is nothing but whatever the primary load cases you are giving. Load case, you can see loading types in the primary load cases. There are dead, live, roof live load, wind, seismic, snow, fluids, etc. All these things. Based on these loading types, it will provide automatically load combinations. These are the 4 cases. So since it is a simply supported beam, I'm going with primary load cases only. So first of all, I'm defining a dead load. Load number 1, dead load. I'm going to give a title of dead. Okay, dead load, add. Okay, first load I have added. The second load is I'm going to give a roof live load, or simply I can say live load. Okay, since it is a beam, I'm going to give a live load. Okay, that thing. I have added loaded types. Okay, and I'm closing this tab. So if you observe, there are two cases created here. Okay, so first of all, I'm clicking the dead load tab. So in the dead load type, I want to add my values. Okay, so if you see here, there are some set 10 components here. So first of all, in any structure, dead load is the main portion, is not dead load is the main portion of self weight of structure, right? So I'm going to give self weight in the dead load. So you have to give self weight load. Okay, self weight load. What is the direction you have to apply? Self weight will be always gravitational downwards, right? Gravitational downwards. Gravitational downwards is nothing but along the y. Y it is -1. Okay, if you observe this -1 is nothing but -1. If you give +1, the load will apply vertically. If you give -1, the load will apply vertically downward. Okay, so -1, because if you observe UCS icon here, y will be positive upwards. Here you can observe y will be positive upwards. So this is a gravitational force. Self weight is a gravitational force that should act downward direction, right? That's why I am going to add negative y. That's why I'm going to use the factor of -1. Okay, some customers will ask for you factor of self weight factor of 10% extra. So in that case, -1.1 you have to take 10% extra self weight. They'll ask for you, some customers, but this is the basic concept. I'm going to use -1 factor only. Just I'm going to add. Okay, and another thing, I'm going to explain you a simply supported beam with, suppose let us take a UDL. Okay, UDL is member load. Nodal load is nothing but, okay, you have seen these components, right? Self weight is, we have given what we have given, you have seen. Okay, nodal weight is nothing but this weight will be applied in the nodes only. It will not come to the member. Okay, it will apply on the nodes only. But we are applying universal UDL on the beam only. So I'm going to apply member load. In that you can see uniform force, uniform moment, concentrated force, concentrated moment, all these things. So I'm going to give UDL. So I have selected uniform force. I'm going to give -2 kilonewton. So why I have selected -2? Again, minus is nothing but gravitationally downward. So you have, if you forget minus here, the load will act vertically upward. Okay, so you have all the dead load is gravitationally downward, right? So I'm going to give -2. If you give +2, this will act upward. So that's why I'm going to use -2 so that it will act downward direction. Global y direction. Local y, every component will have local and global axis. If you take an I section here, the x direction will be like, y direction will be like, z direction will be like. Okay, global y direction is nothing but the UCS icon. It will follow the UCS icon showing here. Okay, so this is all about global y. So you have to add, you have to click add and click close. Okay, if you observe, these two are having question mark symbols. Question mark symbols, why it is showing question mark symbols is nothing but we have created a node, but we did not assign this load to any member. So now we are going to assign. First of all, I'm going to assign self weight to the beam. There is only one beam, right? You can select this beam, assign to selected beam or plates, assign like this also you can do. Another one, another way, I'm selecting another load. Okay, assign to view. Only one beam is there. So assign to view. What are the sections you are seeing here? You can apply that to that view. Okay, I'm assigned to view. I'm assigning the load. Okay, if you observe, this is the UDL, right? So I have given dead load and another one live load. So I'm going to add live load here. Okay, so the same thing, member load of UDL Uniform force, I can say, suppose let us take -3. Okay, fine. In global y direction, minus is nothing but vertically downward. So if you want to apply full moment, full load on the entire length of the beam, so you should not give these components. Everything will be 0. You can observe this one. D1 is nothing but starting point of the beam to the starting of the load. D1. If you want to give a load from a particular point, you have to use D1, D2, D3. Okay, but I'm going to give the entire, I'm going to give load on the entire length. That's why I'm not using any of these parameters, so that it will apply on the complete length of the beam. I'm going to add close. So you have to apply this load to the beam, and you have applied, right? And the next concept, loads, you have applied loads here. And the next concept is analysis. So analysis is nothing but to perform analysis, you have to give some command. Okay, that is perform analysis. Okay, there are P delta analysis. P delta analysis is a secondary analysis that is created. The additional moment will be created due to horizontal deformation, like that. Okay, that is P delta analysis. We are doing simply supported beam. Just go to perform analysis. So load data. If you want to print anything in the output, you can select any of these. Load data, static check, static load, mode shapes. This is all related to seismic mode shapes. And both is nothing but static load, static check and static loads, and all. If you want to print everything, all these things, you can select all. But I don't want any output here because I can check my own. So I don't want to print anything. You can add, close it. Perform analysis, you have added. Okay, I'm not going to design anything. Just I'm going to analyze the beam. I'm not going to design the beam. That's why I have added everything. Okay. So after giving every property to the beam, just go to analysis and design tab, run analysis. Okay, it is asking you to save the structure, as I am saving, and it is analyzing the structure. So you can see there are 2 warnings or 2 notes. Okay, so let us see. You can say here view output file. You can go to view output file from the here itself. Okay, so I am opening the output. Okay, it is showing some instability at the joint, like this. So it is talking about very weak spring added for the stability. Okay, so I'll show, because I'm doing it as the plain structure. If you first of all, here you have a command file. I told you already, a command file, or simply you can say stat editor. Because I'm doing a 2D program, but I'm giving command as space program. That's why it is asking like that. So instead of space, I'm going to use a plane. Okay, I'm doing 2D structure only, right? So I have changed it to plane. Control S, Control F, Control S is for save, and I'm going to close this one. And okay, go to analysis and design, run analysis. You can do. So there is another shortcut you can do, run analysis, Control F5. Okay, Control plus F5. So have you seen any warnings or notes here? No, it is all about 0, 0, 0. So 0 errors, 0 warnings, 0 notes. So nothing wrong in the structure, right? Nothing wrong in the structure. So done. So let's go for analysis. So suppose here, where is that? Yeah, post processing. Post processing is there now. So if you click post processing, here you have to select what are the load cases you have to apply. So I'm applying all these things. MZ. So MZ is nothing but moment about Z axis. Okay, Z is nothing but perpendicular to our screen. MZ is nothing but you are seeing the moment due to live load. You can select anything, dead load, live load here. Okay, this is all about by checking the moment. Okay, otherwise in analytical model also, if you double click any beam here, okay, I'm again telling you, if you double click beam here, it will show you geometry, property, loading, shear, bending. So I'm going to check the bending moment due to dead load or live load. Okay, bending Z, MZ. Okay, bending Z is nothing but MZ. Okay, this is the value. Okay, you can check it with manually because I am taking live load case, right? So what is the bending moment formula for a simply supported beam carrying UDL over entire length? What? Can anyone have idea?
WL square upon 8.
Yes, WL square over 8. WL square by 8 simply. So just check it manually because analysis is correct or wrong. You have to see. Probably machine will not give anything wrong, but just for the sake, I'm telling you what is the live load value I have given 3 meters, right? Yes, 3 meters. So W means 3 into L square. L square is nothing but beam length 5 into 5 L square divided by 8. So what is the value here? You got 9.375. So that is 9.38. It is of 2 decimal accuracy. Okay, 9.38 you got. So you can check it by using manually. So you can also find a deflection here. A dead load deflection. Sorry, in which direction the beam will deflect? Only Y direction, no? So beam will deflect like this. So what is this direction? This is all Y. So dead load deflection, live load deflection. So you can check it here. So what is the deflection formula for a simply supported beam carrying UDL over entire length? Can anyone tell?
WL की power 4 upon 384 EI.
Sorry, again.
WL की power 4 upon 384 EI.
No, you have missed
5 upon 384.
Yes,
yes,
exactly.
Sorry,
5 upon 384. Yes, exactly.
Yeah,
5 WL power 4 upon 384 EI, right? So that is how you have to calculate the deflection. You can calculate I value by your own. Okay, because it is an I section.
Sir, please explain global and local deflection, please, sir. And there are 2 types: global deflection and local deflection. Which one should be checked?
No. Just I will tell you global deflection and what is meant by global deflection and what is meant by local deflection. In the beam, since we don't have any connecting members here, right? We are not having any connected members here. So it is going the deflection for entire beam only. So it is called as global deflection. Yes. If you go to local deflection, Y direction, suppose if you have, just I will draw something so that you can understand. My drawing is not that much clear. Okay. Okay, suppose I am taking a structure like this. Okay, fine. Okay, this is the point where I need to check the deflection. Or otherwise, if you suppose I'm talking about the beam, right? So if you want to check the deflection at this point, so if you click local deflection, that is dead load and live load deflection in this beam only. It is not taking in deflection due to secondary members. Okay, for example, if you click before going to the global deflection, so there will be deflection in the column also, right? Because you are applying here load like this, sorry, vertically downward. Okay, vertically downward you are applying load. So if the if it will deform like this, the column will tend to move in this direction, right? So it will also cause some extra deflection in this beam that we can call secondary deflection, I can say. Understood?
Sir, which will be considered as per the table 5, span upon 30, span upon 300, and span upon 180.
Sorry.
So in code it is given in table 5 or 6, span upon 180, span upon
180,
300.
exactly.
So which type of deflection will be considered?
Global only, not the local one. That is what I'm telling you here. Okay. So the structure will deform entirely. If we apply load, the beam only will not deflect like this, right? Since the beam is connected to the column is also tend to move in this direction, right? So if it is tending to move in this direction, it will cause some additional deflection, right?
Means global deflection will be always larger.
Exactly.
Than...
This is the global deflection. This is the local deflection.
Okay.
Global deflection only you will check, not the local deflection. Clear? What is the difference between local and global deflection? Clear?
Yes, sir.
Right. So I'm going to do this one. So okay. Have you calculated anyone for this section? What is the moment of inertia? Ix6, or I can say Izz. Have you ever calculated for this? I'm going to give you the property values here. So what is the moment of inertia formula?
BD cube upon 12 plus A y bar minus y ka whole square.
Yes, exactly. You can take B or BD cube by 12. What is the B is nothing but, suppose I'm going to draw. Where is that one? Yeah. Suppose right. Okay. Nothing but 150 by 6, right? We are taking. And this is 400 by 5. And this is again bottom flange is also same as like top flange. So I am calculating the moment of inertia for this section. Okay. Okay. So this is all about 400 by 5, 150 by 6, 150 by 6. Just I am telling you how to calculate all these things. Top flange TF I am doing. Okay. This is 150 by 6. So what is the moment of inertia of this section? So B d cube by 12. B is nothing but width and H or D is nothing but depth or height. BH cube by 12 you can say. Okay. Individual moment of inertia for a rectangular section. All your guys telling that is only for a rectangular section. I am doing it for an I section. How to do that? I am telling you. 150 by 6. Okay. So B d cube by 12. B is nothing but 150. D is nothing but here. Okay, because where is that? Yeah. Okay, this is the thing. Okay, suppose this is the I section B is nothing but this horizontal dimension. D is nothing but this thing. Okay, I'm going to find the moment of inertia about this neutral axis. So BD cube by 12. B is nothing but 150, or otherwise just I'll find out in meter power 4. Okay, so 0.156 into BH cube by 12, right? H is nothing but 0.006.
Sir, 0.156, no.
Sorry?
0.15.
Okay, 0.150. Clear? BH cube by 12. Okay, this is the thing. BH cube by 12, right? So I'm taking web. What is the web dimensions? 400 by 400 by 5. I'm taking the web dimensions. What is the B here? B is 0.005. Okay, 0.005 into H is nothing but this one now. Okay, 400 nothing but 0.4 cap 3 divided by 12. Okay, this is the one. And again, bottom flange is also the same thing as top flange, right? So this is all about individual moment of inertia for rectangular sections. So I'm going to find moment of inertia about this neutral axis. Okay, so IXX, sorry, IZZ. So I think all of you have heard about parallel axis theorem. So what is parallel axis theorem? IZZ is equals to IXX plus AY square. Okay, this is a parallel axis theorem. By using that, I'm going to use this. Okay, IXX. So this neutral axis, suppose it is a symmetrical I section, the neutral axis will be at center, right? So IXX, this one plus A. What is the area of this section? 0.150 into 0.006 area into y square. Y is nothing but the distance between neutral axis to the centroid of the particular section. So since it is having 6 mm, the centroid will be at 3 mm for this rectangular section. So this 3 mm plus 400 by 2, 200. 200 plus 3, 203. Everyone got? Have you got 203? Everyone understood?
Yes, sir.
Okay. This is for top flange plus this one, web. Okay, so the neutral axis of the web and the neutral axis of the complete I section is same because it is symmetrical, right? So there will be no y. So the second component, AY square component will be 0, only IXX will be there. So this thing plus, again it is same for bottom flange, right? So what is the IZZ value you got? Sorry, I'm taking some extra class for you. Please don't feel anything. Okay. If you want, you can leave because there will be recorded section. There will be recorded session. You'll get all those things. Okay. So IZZ. So if you double click here, it will show some property here. Okay. What is the IZZ value here you got? You can understand 0.00001000848. All this will be in meter units. Okay, so IZZ, what is the units of moment of inertia? Area moment of inertia, right? Area into y square, meter square into meter square, meter power 4. So units will be meter power 4. So 0.00001000848 meter power 4. What value we got? 0.00001000848 meter power 4, right? The same value we got it here. So IZZ. So W 5WL power 4 by 384 EI. Yeah. The another component you need is E. What is E? Young's modulus, right? What is the Young's modulus of steel?
2 into 10 power.
Yes, 2.05. I can say exactly, right? 2.05 into 10 to the power of 5. What is the units of this value?
No units, sir.
Huh? Who is that? Young's modulus does not have any units. Please recheck. If you are responding well, I will get more interest to explain you because you are listening the time.
Same as stress.
Yes,
Newton per mm square.
exactly. Why? I'll tell you. Okay, what is the practical formula for E?
Stress upon
Stress by
strain.
strain, right? What is the stress? Load by area. What is the units for load? Kilonewton or Newton? Suppose let us take Newton. Area. What is the units for area? Mm square. So stress value will be in Newton per mm square. So Young's modulus is stress by strain. Will strain have any units?
No, sir. No, sir.
No, right? Because it is of relative displacement, right? So it will not have any units. So stress by strain, because not have any units, the units of Young's modulus will be the same as the units of stress. Understood? So 2 into 10 to the power of 5. This is in Newton per mm square. Because all the items we are doing in meters. So this should be converted to meters, kilonewton per meter square. So 205,000 into, if we convert millimeter square into meter square, that will minus 3. Okay, 10 power minus 3 whole square. It will be in the denominator. Okay, 10 to the power of minus 6 will be in the denominator. So it will, if it will go to the numerator, it will get 10.6, 10 power 6, right? Anything have confusion, please don't, anything, do not feel free to ask me. Okay, divided by 1 Newton is equal to how many kilonewton? 1 by 1000. So this is in kilonewton per meter square. So all the values you got. So what is the deflection value? I'm going to find deflection 5 into W. What is the live load value? Because I'm calculating all the values for live load only, because dead load is included with self weight of the structure. Because we don't know the self weight yet, I'm checking the deflection for live load only. Okay, because you people can simply understand, because live load is having only particular load, but dead load is also included with self weight. So the moment will be higher than would calculate.
Right, sir.
Okay, fine. Okay, that's why I'm taking live load to explain to you. Okay, 5 into, what is the formula? 5W L power 4 by 384 EI. 5 into, what is the value of W? 3 kilonewton per meter. 5 into 3 into, all the units are in kilonewtons and meters. I'm taking 5, W is 3, L power 4. Our length of the beam is 5 meters power 4. 5W L power 4 divided by 384 into E into I. Where is the I value? I value. Yeah. Oh, sorry. There is some formula mistake. Huh? Okay. Okay. This is the deflection value. Okay. This is the deflection value due to live load only. This is in meters. Okay. Simply, you can say deflection is in meters. So if you want to do it in mm, this value into 1000. So 1.180 mm. So just check with this deflection due to live load. Have you got it right? 1.181 live load. 1.1809. The same thing, right? If I reduce it to 3 decimal. Okay. I reduced it to 3 decimal. It is in mm. So your calculated deflection is matched with the stat provided deflection value. So everything is right. Everyone is understood.
Right, sir.
Yes, sir.
Clear. So let's stop this session here. The remaining part, nothing but how to design a beam. Okay, by using different codes. We'll see in the next class what are the parameters we give. All these things we'll see in the next class. So till now, it is clear to all of you.
Yes, sir. Thank you.
Thank you for your response. I'll stop this session. Please have a nice week.
Very good, sir. Today.
Thank you. Thank you very much. Sir.
Sir, yes, hello.
Yes, yes, yes. Tell me.
Sir, please open
No?
the sheet, Excel sheet.
Excel sheet. Huh? Yeah.
In ASC seismic series.
AC seismic. Okay, fine.
Yes, sir.
Hmm.
I have calculated okay, wind में जाइए sir, wind ASC.
Wind AC. Okay, fine.
अब इसमें क्या था? एक सेकंड सर 1.49 excuse me sir एक मिनट सर मैंने I have already created a sheet but some problems here. Just a second sir.
What is the problem you got?
Sir, 1 second.
Sir, you can understand Hindi?
Yes, yes, yes.
So let him speak in Hindi so that he can explain his problem.
Fine, fine.
And you can answer in English. Everyone can understand.
Fine.
In wind sheet, sir, wind sheet VZ equals to 49.05 meter per second आ रहा है.
VZ.
एक
Where is
second.
This is our example, no? I'm taking just example.
एक सर इसमें wind sheet में in a wind sheet.
Wind AC or wind IS?
No, yes sir. IS.
Which one? IS, huh? Okay.
Yes sir. Your answer VZ equals to 37.95. I have calculated some formula. It will be 49.9. 49 something 49.5.
Okay, probably I have mistaken here. Anything you want to say? Any mistake? How you calculated? Where it has differed? Can you tell me?
The same I will already create, but
what are the factors you have considered?
Same factors considered.
Same factors considered, huh? Okay.
Yes, sir.
Okay, probably the calculation is wrong, huh? Here.
Yes, sir.
Just I'll check manually. Okay, let me see. in Excel sheet, if I miss anything, if I give anything into as plus thing, that formula will differ actually. That's why everything should be clear. 33 into K1 when K2, everything is 1.15. So everything is one. This is the only one thing you have to multiply 1.15. 33 into 1.15. I am getting 37.95. Any others have this problem? Any other have my formula mistake or something? Anything?
Sir,
Did you get any others?
I didn't check the calculation. I will definitely check today.
Yes. Please. Because probably I have mistaken here. Okay, please. I think I have written the same. Right. What you got exactly? Someone is asking. Yes.
Sir, in this formula, 1.5 into 33.
No. 1.15.
Oh.
Okay. Okay. Probably that is the mistake you are doing.
Oh, yes, sir.
Okay.
Yes, sir.
Okay. Fine. So everything is clear.
Yes, sir. Thank you very much.
Fine. Thank you very much. Please have a nice week, and let's meet another Saturday. Thank you.
Thank you
For
Oh,
one and all.
thank you.
Bye.